All right, let's go. Lana's my camera person. Deep Purple, Kentucky Woman. I don't know, 1972? Yeah? Kind of sounds like Mitch Ryder. You guys don't know any of this stuff, do you? Cody's digging it. Dig it! Work! Okay, now, we want to, I want to do a problem. Now, I have a box. I have a box. And I'm going to accelerate the box. I'm going to accelerate the box, okay? And the box is going to go, then after it accelerates, it's going to be at 5 meters per second, all right? The box. Now, this is the problem. Once the box is at 5 meters per second, it's going to slow down to 1 meter per second. Now, what's that called? If something changes its velocity, what's that called? Deceleration, acceleration, negative acceleration, right? Okay, good. Now, so this is the free body diagram right here, correct? Now, when it slows down from 5 meters per second to 1 meter per second, what's stopping it? Friction. Friction. So what's the net force? What's the only force acting on it? What's the net force? What is the net force? What's the only force acting on it? Friction. Yeah, there you go. So this is what I want you to do. I want you to find the change in kinetic energy. I want you to find the work. I want you to find the friction. And I want you to find the net force. If a box going 5 meters per second, that's 5 kilograms, slows down to 1 meter per second. Now, let's look and see what some of the things we want to use, okay? We want to use this for kinetic energy. You ready? Okay. The change in kinetic energy is going to equal 1/2 the mass, right? Times what? Times what? Difference of squares. Times what? Times final velocity squared minus initial velocity squared. Right? That's going to find the change in kinetic energy. What was the kinetic energy when it was going 5 meters per second? What was the kinetic energy when it was going 1 meter per second? What's that change in kinetic energy going to be? Things you want to ask. What is the sign going to be? Positive or negative? And why? All right, well, don't tell me yet. Let's work on this. Second thing. What's the relationship between change in kinetic energy and work? What is that? What is going to be the equation to find the frictional force that actually stopped it, the net force? What's the net force going to be? What's the net force going to be? Because we don't have a time. We don't have a time involved here. But the net force is actually kind of easy because you know that work equals force times distance. So what do you have to do? First of all, you have to identify the work. You have the distance. Solve for the force. Now, that force you solve for, what is that force? You got to identify that. So the calculations are actually quite easy. It's interpreting the answers that are going to be the significant aspect of this problem. Okay? All right, let's shut it off and let's try to do it.